All right, so the instructions on here are construct a line parallel to line L, but there's a stipulation here, not just any line parallel to L, but it has to pass through point P. So we're going to see if we can do, with just a straight edge and a compass, if we can construct a line parallel to L through point P. So we're going to start by doing it with a compass, and then we'll talk about other ways we could have done it other than using a compass. So I want everyone to start on their paper by putting a dot, a point, somewhere on line L. And if preferably, if you can put it to the left of point P like me, not because it has to be to the left, but because if ours match, I'll be able to teach you better how to do this construction. So put a point on line L, put it to the left of P preferably. Then I want you to take your straight edge, take your ruler, and connect the point that you made and connect P. How many lines are there through those 2 points? How many lines exist through those points? If you said only one, you are correct. So what we do want to be careful of, let's see how I get my, just have to get my pointer back. What we do want to be careful of when we do this is that a couple of things. You see that line, that point P? That is the thickest point I have ever seen. So be so careful that when you're doing your construction, you're really eyeballing the middle of that point. That is way too big of a point. Our answer might be totally off if we use the edge of that point instead of the middle. So kind of picture the bullseye of that point and do everything through there, because that point P is like unusually large. It's really weird. So all we've done so far is connect 2 points. Now what we're going to do is going to be beautiful. We're going to use one of the theorems we learned, and we're going to use that theorem to construct a parallel line. Let me give you a hint. I'm going to hint to the theorem, and I'm not going to use any words. Are you watching? What did I just do? Does anyone know what theorem I just used? Because that's what we're going to use to construct our parallel lines. What's this called? Yes, you got it. First one, Jesselyn. What's this called right here? That is an angle. Yes. So what I did was I traced the angle I made through that line in line L. I traced it. And then I simply did a translation. I translated it so that the vertex is not that point I made. Now the vertex is point P. And if I were to draw that line, which I'm not going to yet because I haven't used a compass yet, if I were to draw that line, those would be corresponding angles. We learned the converse of the corresponding angle theorem. We learned if corresponding angles are congruent, then our lines are parallel. So we're using the converse of the corresponding angles theorem to force parallel lines. Now, what is this called? I can't translate with a compass. What construction are we going to be doing? What do you think that's called? We're not going to be translating an angle. We're going to be, starts with a C. Almost, Sharon. She said congruent angle construction. What are we going to be doing to that angle? We are copying an angle. It's called copying an angle. You've already learned how to do it in the angles unit. So now you probably wondered, why did we even learn how to copy an angle? Well, it was for stuff like this. This is what it's for. So let's copy an angle, not using a fancy smartboard, but using a compass. So to copy an angle, first you put your needle on the vertex. And you make an arc. So everyone do that. Needle on the vertex and make an arc. Then you take your compass and you move your needle to the middle of point P. Not the edge, not the side, the exact middle of point P. Points aren't supposed to have middles, but our point has a middle because it's unusually large. And you make the same arc. So far, all I have are identical arcs. They match. I put the needle on one vertex, then I put it on the other vertex. The next thing that we do is we take our compass and we go over here and we find out how big the opening is of our angle. The way we find that out is we put needle on one intersection and pencil on the other. And I'm doing the best I can with my smartboard compass. That's as close as I'm going to get. So needle, pencil, both on the places where that arc intersects the angle. Then you move it and you put the needle in the exact same spot. Like that. Needle, pencil, needle, pencil. That's when you get your straight edge out, you get your ruler out, and you connect the middle of point P with that intersection that you just got. Mine's a tiny bit off because of the smartboard limitations. And then you can add arrows to show that you just constructed parallel lines using the converse of the corresponding angle theorem. Dun, dun, dun. Okay, so here's a review about a perpendicular bisector, because we already constructed these in another unit and we had you do it on an assessment as well, the boating in the moonlight. Perpendicular bisector, that vocab word is really a two-word vocab word. So this part of the vocab word brings what to your mind? You should be thinking of, oh, when two slopes are perpendicular, the product is -1. Oh my gosh, that's fancy. Okay. What else do you think of when you hear perpendicular? 90-degree angle. Yeah? So perpendicular, you should think of a right angle, a 90-degree angle, just two lines that intersect at a 90-degree angle. Now perpendicular is the first part, and bisector is the second part. What do you think of when you hear bisector? Middle, congruent, half and half. Oh my goodness, y'all can just teach this lesson. So bisect, I've taught y'all, means cut in half. And we're going to leave it at that for a minute. We're going to leave it at that because I don't want to give something away. All right, so which one of these on my board are real perpendicular bisectors? Let's name them. Which one of those are true perpendicular bisectors? Y'all are too good. It's A and D. Very good. Because you have to have both sets of symbols to be a true perpendicular bisector. Both sets of symbols. This is simply perpendicular only, and this one, the only thing it's doing is bisecting. It's not bisecting at 90 degrees. Okay, we've already learned this before, so I'm going to remind you how to construct a perpendicular bisector, and you can do it with me. Step 1 is to put your needle on one of the endpoints. Needle on one of the endpoints. Step 2 is to open your compass, doesn't matter how much, but more than halfway. So you just kind of eyeball it, you're not measuring anything, you open your compass more than halfway. The larger you open your compass, the more room you're going to take up on your papers. You might want to be a little bit closer to the middle. You draw an arc, and then you flip your compass over, put your needle on the other end point, and draw the identical arc going the opposite way. I sometimes call it the opposing arc. Easiest construction ever. Then you take your straight edge, you take your ruler, you connect dot to dot, and that's how we taught you to find midpoint actually. So when we taught you to find midpoint, we were actually teaching you more than that. We were teaching you how to find the perpendicular bisector, but all we needed at that time was a midpoint. Perpendicular bisector. So do the construction, mark up your picture, and then we're going to talk about it because this is old news. We want to go deeper. We want to go further. Okay, so now you have a new line, and I want you to pick any point on that line, any point you want. I want you to all pick different points and call it P. I'm going to pick this point down here. But you're picking any point you feel like. You're not picking one in the same place as mine exactly. Pick any point and call it P. Now I want you to draw segment AP and segment PB. What does that mean? What tool are you getting out? You're getting your straight edge out, and with your straight edge, you're connecting P to A. See if I can do this on the smartboard. And connecting P to B. A ruler doesn't work on the smartboard, so just pretend that mine's perfect. Now, also pretend that you have patty paper, but you can just use your ruler. I want you to confirm, I'm already telling you the conclusion, guys. It's out there. I want you to confirm that the distance from A to P is equal to the distance from P to B. I want you to either, you don't have patty paper, tracing paper, or your ruler to confirm that no matter where you put P, I don't care where you may have placed it, confirm that the distance from A to P is congruent to the distance from P to B, or equal to, rather, I'm sorry. And you may add tick marks appropriately to your picture. So the distances are equal, which means the segments are congruent. So another way to write that is like this. Okay, we're going to move on. I'm going to ask you some more questions. Look at the next picture on your notes page. The picture underneath the construction you just did. I want you to write a full sentence. So start with a capital and end with a period. That's what my first graders learning, how to write complete sentences that start with a capital and end with punctuation. Anyways, write a sentence about the picture below. And I want you to use the word equidistant, but I'm going to add another word that I need you to use because first period wasn't really getting where I wanted them to get. In your sentence, you must include the words any and equidistant. And it has to be about that picture. So you should be using those letters as well, A, B, C, D. What does equidistant mean, guys? It's a really fancy word, but all it means is equal distance. Thanks, Google. It just means equal distance, okay? Here's what I was going for. Okay, so I wanted you to use the word any, so I would have started with the word any. Any point that lies, what do you think the next word was? Any point that lies on what? Good. Any point that lies on line CD is, and I was going for equidistant. And then a lot of you said to, but I would say equidistant from points A and B. So what we would not say is that segments are equidistant. The segments are congruent, yes. If I were to put a point, but we don't have a name for these points yet. But if I were to put a point, the segments would be congruent. But don't say the segments are equidistant. You would say that point star, is equidistant. It means it's the same distance away from A as it is from B. So you wanted to say that the point was equidistant, not the segments. And notice I didn't say anything about segments. Those segments just give us a visual of what the distance is from the star to A and from the star to B. All right, so what we pretty much just did was write down the perpendicular bisector theorem, which is already on that big notes page where you have all your theorems in one place. It's already there, so don't write it. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And that's any point that we want. So that's the theorem. That's today. Okay. I want to ask another thing real quick before we do this. With that theorem in mind, we know there's an infinite number of points that lie on the perpendicular bisector, right? So here's A, here's B, here's the perpendicular bisector. All of these points are equidistant, all of them. Describe the point of all of those points that I just drew that is the closest to the end points of the segment. which point on line L is the closest to the end points of the segment. Oh, good. Ooh, don't do plural. There's not more than one. The midpoint. So out of all those points that exist, you and you and you, they're all equidistant. But the only one that has a special name of all of those points, the one that has a special name, is the midpoint. Oops, that was weird, sorry. Of AB. Okay? So there's one point that lies on the line, and it's special, and it's the midpoint of AB. The hero. Yes, okay. Your graph on your notes page, I want you to plot points A and B, where A is 1, 1, and B is 7, 5. And then I want you to create segment AB. Using a compass is not the only way that we can draw a perpendicular bisector. What other tools could we use to draw a perpendicular bisector? What other tools? A right angle. That's not a tool. Good. A compass we already used. Wait. Yes, Sharon, we're about to do that. What other tool, though, before we do it on the graph? There's one more tool you could use. A pencil. Not patty paper, no. A straight edge, a ruler actually. You would need a ruler and what else? The ruler could find you the midpoint. You would need something to make a 90-degree angle. What's that called? So you would need a ruler with markings on it and a protractor. So the ruler could find you the midpoint, and the protractor could make you your 90-degree angle. So we could use a compass, we could use a ruler and a protractor, and now we're going to learn how to do it on the coordinate plane. So y'all have plotted those points and you've connected them to create segment AB. Now I want you to draw the perpendicular bisector of segment AB. So how would we do that? What do y'all want to do first? We're going to have to do something that has to do with this and something that has to do with this. What do you want to do first? No, we're not using these. We were just talking about a different thing we could do. You want to do perpendicular first. Okay. How could I make sure that I'm perpendicular to segment AB? I wouldn't go with the -1. Use the other phrase. We're not going to use any of our tools because we're on the graph now. We're on the graph. I'm looking for a word that starts with an S. No, not find the length. I want to be perpendicular to AB, and I want you to use a word that starts with an S. Slope! Hallelujah! What is the slope of AB? Rise 1, 2, 3, 4. Run 1, 2, 3, 4, 5, 6. Rise 4. Run 6. Oh my goodness, we made it. The slope of AB is 2/3. So what would the slope be of our perpendicular bisector? Good. Okay. That covers the perpendicular part. We're done. Now we need to bisect this segment. How would you like to locate something that would help us bisect? There we go. Midpoint. We need the midpoint of segment AB. Do you already know it? Well, if you rise 4 and run 6, then just rise 2 and run 1, 2, 3. What is the midpoint? Y'all getting 4, 3? No, I want the point. I don't want you to say half. I don't want you to find the distance and divide it by 2. I want a coordinate, guys. A coordinate. That's not a point. So, we have a point and we have a slope. Now we could write the equation of the perpendicular bisector, or now we could plot and graph the perpendicular bisector. So we have a midpoint and we have a slope, so we could rise 1, 2, 3 and go backwards 2. 1, 2, 3, backwards 2. Look at that. That is the perpendicular bisector of segment AB. Let's write the equation because that'll happen on your test. Y equals mx plus, what's b? We're lucky, it's a nice whole number. When we graphed it, it intersected our graph right there at 9. Y equals mx plus b. Okay,